So there's this big debate going on in the tech world of whether or not it's still worth it to learn how to code. Now, I'm not going to say that it's necessary, especially given artificial intelligence, if you want to get something done, if you want something executed. But do I think it's still worth it? Well, I do. And there's an important distinction that makes me believe that's the case. So if you're wondering whether or not you want to, whether it's not, it's still worth it to pursue coding, whether or not it's worth it to pursue that as a skill set, then listen up because we're going to get into it. So is it worth it to learn how to code in 2026? Well, I'm going to open up my argument with a scenario that I heard recently that I think applies perfectly. So there's a group of guys standing on a factory floor and they're trying to figure out what's wrong. There was this issue that went wrong with the machine. And so they call in the most senior person around and they say, hey, can you help us fix out this machine? And it's this old guy. They've been standing there for hours. This old guy, he comes in, he looks around, he's thinking to himself. He examines the machine for maybe a minute or two, takes out a hammer, and boom, hits the machine, and it starts working again. And he says, "Here's your bill, and it's $1,000." The people there say, "We're not paying $1,000. All you did was come over here and hit the machine with a hammer. We could have done that ourselves. We want a new bill." And so what does he do? He drafts a new invoice, and he says, "Hitting machine with a hammer, $10. Knowing where to hit the machine with the hammer, $9,990. Another example is Pablo Picasso. He's sketching on a napkin, and I don't know whether or not this is true, if it's just folklore and rumor, but he's writing on a napkin, and it's this art, or he's drawing on a napkin, and it's this art piece. And he takes this napkin and he throws it out in the garbage. The person grabs it and hands it back to him, and they say, "Oh, this is yours." And they say, "How much for it?" And he says some large number, $100,000. The person goes, "Well, you just threw it out, and you just did that in like 5 minutes." And he goes, "Yeah, I drew it in 5 minutes, but it took me a lifetime to be able to do that in 5 minutes." And both of those stories, both of those circumstances point to the reason why somebody should learn how to code. But I'm going to take it one deeper. I'm going to go a level deeper because I don't know if that just cements the need, and then we'll unpack it. Coding is not the same thing as programming, and it's not the same thing as engineering, and that's an important distinction to make. But we're just going to focus on programming, and we're going to focus on coding. Programming is something that people do in their lives all the time. Programming is, we see it on TV, we see it on the videos on the socials, especially on Netflix now, Amazon Priming, they're programming. We see it in people that throw events. What's the program? What's the agenda? The program is just the intended set of steps or instructions or things that people need to do given an event or something that's planned. It's a planned set of actions that people will be doing. It's a planned set of events, a program. We program. Coding, on the other hand, is taking that program and transcribing it into something that a machine can learn. So is coding dead? It's probably not going to be used as much as it was in the past. I mean, I find myself using less and less hands-on code, but I do find myself programming way more than I did in the past because I'm not constrained by code anymore. I can set more programs and have machines do what I want in an automated way easier than I used to in the past. I'll give you an example. Before, when I wanted to write a program, I had to write if-then loops. I had to write if-then statements. I had to write for loops. I had to write code. I had to understand the language that I needed to write. I needed to understand Python, Go, C#, C++, JavaScript, you name it. Now, because of artificial intelligence, because it's gotten so good at predicting what I actually want, now all I have to do is write what I want in English or whatever your native language might be. And the machine has gotten so good at interpreting English, the language, into coding the syntax that it can make that translation for me. So programming is not the same thing as coding. You can program without coding, but your programming gets better when you understand how to code. Why? Because you understand what's going on a layer deeper. Now let's get into that a little bit more. Computers, our ability to train a machine to compute information started as a set of zeros in one. Actually, didn't even start there. It started as logically on and off switches. Think on means yes, off means no. This is where we get the bits from. And this is the work of Claude Shannon. Fun fact, Claude AI is named after a guy named Claude Shannon. And Claude Shannon was the guy who invented the mathematical theory of communication and formalized the bit, the binary digit that we use right now to track information. And when that, because we can track information, that means that we can turn that into something that's useful. We can build programs off of these binary digits and a series of yes, no, yes, no, yes, no's, and that's where the logic of software engineering comes about. I like to think of software development. I like to think of software as the language of logic. That's the skill that software developers have. We just understand how to take logic and make it useful and solve people's problems. So we started with these yes nos as real switches. Then we ended up moving that into a more efficient way and scaling that up into what we see as modern computers today. Now, without getting through going through the details of the history, over time we've abstracted from the yes no switches and we've developed easier and easier ways to program what we're keeping track of. And that's led us to a point where right now we've gotten so good where we can take an English sentence, email me at 5 p.m. every day, and the machines are so good at interpreting that and executing off of that that our programming abilities have skyrocketed. And so the need for understanding how to code has dropped significantly. But here's why it's really important to understand code today, or if you are learning how to code, why it's not a useless skill. A big thing about programming is, in programming with machines specifically, is not in the creation of the software, it's in the debugging of the software, in making sure that it's doing exactly what we want it to do or operating within an expected outcome. And that's where the skills become really valuable because you don't know what you don't know. And when you're skilled at coding and understanding how to read code, you develop an intuition about how the machine can work, how a computer can work, and you get an intuition about how, when things go wrong, what's going wrong and how to fix it. Knowing where to hit that hammer becomes incredibly valuable, especially when there's so much slop out there. How do you make sure that it's operating according to spec? And this comes back to my main point, is that today, almost now more than ever, it's important to understand how to code because more and more people will be needing somebody who can understand the nuances of what's going on under the hood, so that way we don't have to um, make things and operate blindly, and we know what to do when something goes wrong. So should you know how to code? I say absolutely. Is it necessary? Not as much as to be productive, not as much as it used to be in the past, but it's still a very valuable skill. Supply and demand. There's less coders out here because more people are just vibe coding and prompting through their natural language, which means that under the hood, it's much more difficult to understand what's going on specifically. And the people that can do that, especially at a high level, will be compensated accordingly. So hopefully that provides you with some help on how to navigate this space. This is Tendo, and this has been brought to you by Contents.com. Contents.com will provide you with, Contents.com is the #1 mini site in the world. It's going to help you make money while you sleep, and it's the site that sells while you sleep. It's very easy to get started as a solopreneur or a small business to grow your team using constants.com. We provide a toolkit, all the things that you need to get started. We help you with payment processing. We help you set up a mini landing page. We help you with a workspace, and we help you convert that workspace into something that can actually tangibly make you money. So if you are sitting there saying, hey, I don't know where to start, then go to constants.com. You can get started for free, and you will be well on your way to either starting a business or growing your business given the tools that we have. Don't take my word for it. Check it out yourself. If this has been helpful in any way, leave a comment, like, subscribe, or share it with a friend who might be needing to hear this for themselves. This has been Tendo. Thank you for joining us on Constant Corner, or the Constants Corner, and we will see you next time. Peace out.